When we turn over question 5, we'll notice something that's sometimes a little bit unfamiliar, in that we've got two different functions for v at different time intervals. So its velocity is going to behave like this for the first bit, and then once we get to t equals 4, it's then going to follow this model. So this is going to make some kind of a graph that maybe changes. It might, well, we can see here, this one's part of a negative quadratic, and this one's part of a negative gradient line. So it might go something like that and then straight down. We could plot this if you really wanted to, but we're not going to. We're asked to work out a number of different things here. We're asked to find the greatest speed of p in the interval here. So the first thing we're going to do for this is we're going to look at this graph here, and we're going to draw a sketch of this so we can work out its biggest value. It may or may not be the turning point. You have to be a bit careful with some of these questions, but we're going to work out what this looks like between t equals 0 and t equals 4. So I'm going to copy down my t equals 0 to t equals 4 bit. So we've got 8t minus 3 over 2 t squared, and this is v. And this is between 0 and 4. So I'm going to draw myself a set of axes over here, and I'm going to dot on the line here at 4. First thing I'm going to do is I'm going to put my endpoints in here. So if I substitute 4 in here, I'm going to get 8 times 4 minus 1.5, which I'm going to use as my 3 over 2 times 4 squared. So if I substitute in 4, I'm going to get 8. So I'm going to plot that there. If I substitute in 0, I get 0. So we know we've got our two endpoints. I'll move that up so you can see it. We've got our two endpoints there and there. In the middle here, this might go further up. It might still be on its way up, and we're just asked for the maximum greatest possible speed. So if this goes up further, this is going to be the greatest. If this is still on its way up, that's going to be the greatest. So we need to work out if there are any turning points. So we're going to take this and we're going to differentiate it. So we're going to get dv by dt equals 8 minus, we multiply this, we get 3t. If we rearrange this, or set this equal to 0, we get t equals 8 over 3. 8 over 3 is, well, 6 over 3 would be halfway, so it's about here. And if we take this t value and we substitute it in here, we get 8 times 8 over 3 minus 1.5. I'm going to put this in brackets because the calculator sometimes doesn't like squaring things. 8 over 3 squared. We put this in, we get 32 over that, which is 10.66. So this is up here. Above this, but it's also above the 8. So our velocity looks like this. I'm going to rule this in. So we're asked for the greatest speed, which is either the highest bit up here or the furthest bit down here. Because remember, negative velocity is just speed but going backwards. So here is our value for part A for the maximum speed. So this is our max speed, which is there. For part B, we're asked to find the distance from the origin when t equals 4. So you'll notice this one ends at t equals 4. This is where the t equals 4 is kept. We're not allowed t equals 4 in here. This is strictly greater than 4. So we're going to have to integrate this using our initial information that t is 0, it's at the origin. So we've got s equals the integral of 8t minus 1.5 t squared dt, and we know that v equals 0, sorry, s equals 0 at t equals 0. So we're going to take this information, we're going to integrate it, so we get s equals 8t squared over 2. This was 3 over 2, so if we integrate it we're going to get minus 3 over, so add 1 to the power and then we divide, so we're going to get minus 3 over 6 t cubed plus c. We only need one constant here because we don't have any vectors. Plugging in the information, we get s equals 0, which is equal to 0 minus 0 plus c. This gives us that c equals 0. Even though c came out to be 0, you'll still lose a mark if you forget to include it and you forget to check it in the exam. Because as mathematicians we need to be a bit more rigorous than just getting lucky because the c actually happened to be 0. So we have s equals, tidying this up, we get 4t squared minus a half t cubed is our expression for distance. And if you go back to the question, you'll notice that we were asked to find our distance at t equals 4. So at t equals 4, we have s equals 4 times 4 squared minus a half, also 4 cubed. Putting this in the calculator, we get 64 for the first bit. Take away a half of 64, which gives us an answer of 32. So that is our answer for part B. When we come to part C, there's a 1 marker here, so we should be able to do this really quickly to find out the time for which P is instantaneously at rest. So if we have a look here, find the value for t is greater than 4, so we have to look in here and find out where t is instantaneously at rest, so when the velocity is 0. So hopefully we can look from this and write down v equals 0, which is equal to 16 minus 2t. So 2t has to equal 16, so t has to equal 8. So this is the point where v equals 0. So we took our velocity, we made it equal to 0, we found a t value. Okay, we're asked to find the total distance travelled by P in the first 10 seconds of its motion. We should notice that this is worth 8 marks, so this isn't going to be something we can do immediately. But actually, we know the distance when t equals 4. So t equals 4, we know that s equals, we worked out before, it's 32. So this came from part B. So we're now doing part D. So we need to work out a bit more. Part C is also quite interesting because it was going forwards and we know that t equals 8, it stopped. So it's actually going to be coming backwards. So 0 less than equal t less than equal 8, we're going forwards. And then it changes direction because this velocity will become negative. So between 8 and 10 it's going back. Which does actually make a difference because we're asked to find total distance travelled, so we need to do the forwards distance plus the backwards distance. Because if it said displacement, we just go straight to 10, but because we're after distance travelled, we need to do the forward bit and then the backward bit. So we're going to have essentially something that looks like this. So we need to work out this distance here, and this distance here, and do 1 plus 2, which will give us our final answer. So we need to find a distance formula from this velocity formula here, so that we can use it. So we're going to have s equals the integral of 16 minus 2t dt, because we've integrated velocity to get to displacement. So we have s equals 16t minus t squared plus c. We integrate this, we get t squared over 2, the 2's cancel. We need to find this plus c, but actually we're not going to use our initial conditions because our initial conditions actually start with 0. And because 0 isn't part of this, we're going to use 4 as our initial condition for this. Because right at the start of here we have t equals 4, which is the kind of boundary point between these two, and we know the distance is 32. So we can get 32 is 16 4 minus 4 squared plus c. So we get 32 equals 4 16s are 64 minus 16 plus c. If we do 32 minus 64 plus a 16, we get minus 16. So we get c equals minus 16. So that is our constant of integration for the second part of the journey. So we have s equals 16t minus t squared minus 16. Okay, so looking at our journey, we need to work out the distance from the origin at t equals 8, and also the distance when t equals 10. And we'll see why these are useful later. So if we sub in this one here, we can sub in 8, and we get 16 lots of 8 minus 8 squared minus 16, which comes out to be, substituting this in, we get 16 times 8 minus 8 squared minus 16, which comes out to be 48. If we sub in 10, we get 16 lots of 10 minus 10 squared minus 16, so we get 160, take away 100, minus 16, which comes out to be 44. So if we were to look at the journey for this, it's gone along this way and then it's come back. So this is t equals 0. At t equals 4, we're at this point that's at 32. Here's 0. At t equals 8, we're at this point here that is at 48. And at t equals 10, we're at this point here which is at 44. So the scale on this isn't brilliant. Let me just move this up. So all I've done is I've put these numbers on a line. So the total distance travelled, we went 48 metres this way, and then we came back 4 metres this way. So total distance is 48 plus another 4, which is 52 metres of total distance travelled. If you just sub in the 10 for the end of the journey, you will end up with 44, because it won't count this extra bit of journey that we actually took. Because you've got to remember that integration will count this as positive and this as negative. Because if you put this in as your final and this in as your initial, you'll end up with minus 4 meters. So integration will count it as minus 4, because we're doing it of distance. We're going to have to count it as positive, and we end up with our answer of 52.